and volume are related by ideal gas law, in which case PV is equal to nRT. That is ideal gas law in chapter 16. Chapter 16. Okay, so we can figure this out. We like to determine. So we know the work is done by pressure and volume. So assume the work now, assume dW is equal to PdV. Now this is a sign very important. If the work is done on its volume changes, so is a work done on the gas. Work is done on the gas. We like to define that as minus. The work dW equal to PdV. So work is done by the gas. So you have to notice that it's on the gas and by the gas, then this is positive. So this is a message we have to inform you on this. So plus and minus. So we are emphasizing here. So the W from one end, this is done on the gas. Is done by the gas. So W is equal to integral of minus PdV. This one is W is equal to positive PdV. So that is a difference. So here is the fact. So in these cases, when you're solving problems, the key thing is in the work related in the chapter 17 is make sure you draw anything related about work is called PV diagram. P is pressure versus V. This PV diagram is important. Be like this. So on this point and this point, then the area is from here to here. Now there's another way to do this. Is so if you can see, even the end product are the same, but basically what we call the work is different. So suppose we go the other route like this. So this is this path. In that case, the area under the curve is this section. And if you go this route, then the area under this section is different, and as a matter of fact, bigger. Now, there's another situation is in here, is P sub I and P sub F. So they start out here and then like this. So in PF differently than I do, because I consider initial points here and go down, and then from initial point go down, so forth. But the basic field are the same. So then we have to learn about another thing. It's called the conservation of energy. When you input the heat to a system, couple things you change. One is doing the work. Another one is going to exhaust, coming out. So basically, the first law of thermodynamics is conservation of energy. Okay, the first law of thermodynamics, section 70.5, the first law in thermodynamics. First law of thermodynamics is equivalent to mechanical engineer part. It's called conservation of energy. So we have a lot of things conservation, right? You have a conservation of mechanical energy. Now you have conservation of heat energy. You have conservation of momentum. You have conservation of angular momentum. All those things related with conservation. That means as a total, it doesn't change. So a lot of time we solving problem is this conservation of energy. Maybe it's heat energy, maybe it's mechanical energy. So this one is related with first law of thermodynamics. So make it nicely is two things. Is one, they written all different form and depends on how you like it. Basically, the proper form is dQ. That means the heat getting in. And then that is equal to dE. That is equal to internal energy. So that is the heat energy. When the heat energy going in, first go into a system. First is internal energy plus another one called PdV, in which cases it's called doing the work. Now this is one form. Okay, that's the sodium form, right? There's another form, you can say Q is in, the heat is coming in, is equal to heat going out, heat out, plus work. Okay, this is another form. There's so many ways to express the thing. When all this happens, internal energy is the heat machine, heat engine. We usually like to express the conservation energy in this form. Heat in equal heat out plus work. And basically, you cannot cut down the heat out equal to 0. Okay? So another information about conservation of energy in a system means it does not do the work. There's no work is being done to another object, one place to another. That means in these cases, no work is done. So the W equals 0. And then the heat is just transferred. Heat is just transferred. From where? From high temperature to low temperature. So in this case, we can say another conservation of energy, conservation of thermodynamic, the first law of thermodynamics. In the system, you have some object is loss of heat is equal another system going to gain the heat. So Q loss equal Q gain. If this is the case, again, is related with conservation of heat energy. Again, is the first law of thermodynamics, heat energy. Today we are doing the experiment based on this. What we like to do is do a simple experiment. And a simple experiment is find out the specific heat of the 3 different metals. For 3 different metals. The 3 different metals per se, we like to using aluminum. We like to use what we call aluminum, and we like to use copper and iron. So we will do this. This one is experiment number 12.